Welcome again. If you did not watch the previous lecture, you want to watch that one first. That was doing logic for the virtual machine. And again, if you haven't watched the lecture discussion on the virtual machine, you need to watch that first. You can't automate something that you don't know. So we have a saying, if you have a process and you want to automate it, but the process isn't right or doesn't work right manually, you sure don't want to automate a poor process. Plus, if you don't understand the process in the first place, you can't automate it. So if you haven't watched Virtual Machine, go watch that, and then watch the lecture before this one, which was on the set logic. In other words, just using latches, and you went all the way through the steps, latching them finished one at a time, and that was a condition to start the next step, and so on. And when you were all done and the finished part left the cell, the work cell, then it reset everything and you could now accept a new part. What we're going to do in this lab project, and it's part of the same project, is that we're going to reset the steps as we go through the steps. So in other words, step 0 is complete, now we can do step 1. And when step 1 is complete, we set that bit, but we reset step 0 complete. Another thing to pay attention to is that we're going to switch from double solenoid to single solenoid. Now we considered them both in the manual, but we want to keep this as mixed up as possible, meaning giving you the most experience, the most variation. So in this discussion, we're going to use the single solenoid logic, but we're going to reset the steps as we go. So let's jump into this. Occasionally, what I put up on the screen will vary from what's in the lab project manual, but the essence is still the same. It's still the same goal. I may change the logic once in a while to illustrate something different. And when we get to this level in at least my lab projects, I'm going to do things different. But I stick to the manual in the early stages so there's no confusion. At this point, I expect you to dig in and develop some roots. In other words, if you can't figure out how this works, if it changes a little bit, you'll never deal with it in the field. So if you get confused at some point, don't give up. Just keep listening, rewatching, and thinking, because that's exactly what you're going to do in the field when you're working on projects. Okay, I've added something a little bit different in this project on screen here. I've added something called single step. So you see in front of many of the rungs there is a single step. And the first one is 0.1 or decimal point 1 of the double integer single step. So single step is a double integer. That means it has 32 bits. I'm not using bit 0. I started with 1. And the goal here is to single step through this code. You may even want to duplicate this in your code to allow you a little thinking time between steps, because the way this sequences through, other than you turning on and off photo eyes, it goes through pretty quick. So let's start by turning on input 0. When I turn on input 0, I get a barcode scanner trigger, and it comes back with a barcode value of 5021. And if it's greater than 5000, then it's a part that needs a hole drilled in it. So we say that we have completed step 0 and there's a new part in the queue. So S0, part in queue. In the actual process, what's happening right now, a part is traveling between photo I1 and photo I2. Now, if it gets to photo I2 and we haven't sensed it with photo I2, then it won't extend cylinder 1 and 2, and we won't pull the part off the conveyor to bore a hole in it. So right now the process is waiting for you to turn on photo I2. So I'm going to turn off photo I1. It didn't have to stay on all this time. As a matter of fact, I'm going to reset this. I'll just start over, hit reset, and I'm going to turn on photo I1 long enough to get S0 part in queue, turn it back off. Now I'm going to turn on photo I1. However, So you see right here, when I turn on photo I1, it's going to extend cylinders 1 and 2. And once cylinders 1 and 2 extended have come on, then that would be this next rung. But we're waiting for the single step to be released. In other words, unless this goes true, it won't continue in the logic. Now, let me back up and do that again. Only this time, watch. Now we've got our part and cue. Now watch the relationship here between when I turn on photo I2 and when it says cylinder 1 and 2 are extended. You'll notice a delay. And now input 11 and 12 are on, and that's signifying that step 1 is now complete. Cylinder 1 and 2 are extended. That delay took place in the cylinders logic for cylinders 1 and 2. Remember, we have a 2-second delay from when I energize output 1 until it says that cylinder 1 extended proc switch is made. This is our simulation of the amount of time that lapses between when you energize the solenoid and the time it takes the piston to travel to the other end of the cylinder and turn on cylinder 1 extended proc switch and cylinder 2 extended proc switch. So that's what's going on behind the scenes. Now you can see with this single step in here that I've slowed it down so I can actually discuss this. You can do the same for yourself so you have time to think. So what's going to happen when cylinder 1 and 2 are extended? Going to turn on the drill motor, and then it's going to complete step 2, which is drill on. And it's going to reset step 1 back here. Okay, so remember, in this logic, when we've completed a step, we release the previous step, or we reset it. So I'm going to toggle single step 1 and watch. The drill motor will turn on, it'll complete step 2, and it'll unlatch or reset step 1. Toggle bit. Now, if I had not put that in there, you would never have seen S1 cylinder 1 and 2 extended, because it happens all within one scan. In other words, within one scan, if cylinder 1 and 2 are extended, right here, in other words, if this is set, this is true, it turns on the drill motor, says step 2 is complete, and it turns step 1 right back off. So step 1 is only true for one scan because it turns on the drill motor. You know, we're not waiting for the drill to come up to speed. Now, we could put a delay in here to allow the drill motor to get up to speed, but we know that when we extend cylinder 4 to push the drill bit forward into the part, that's enough delay for the drill to get up to speed. But we could add that logic in here. That would give you a little delay between turning the drill motor on and saying that step 2 is complete. Okay, so the drill motor's on now, and after 1 second, it will, and that's actually our delay right there on extending cylinder 4. So we do have a delay in there between when we turn the drill motor on and when we actually extend cylinder 4. That is to allow the bit to get up to speed. That way you've got the inertia built up in the armature of the motor, and when the bit hits the part, it's got that little bit of extra build-up energy in the inertia of the armature to get it started without bogging down the motor. So when I release step 2 here by toggling on single step 2, because the drill is on, we start our time delay, and we're going to energize output 4, which is extend cylinder 4 solenoid, and then you'll see a delay here between when we energize the solenoid and when we say that cylinder 4 extended proc switch is on. Okay, you see, it's energized, then after delay, extended proc switch. Now we're declaring that S3 is complete, cylinder 4 extended. And notice that we turn off step 2, which was back here. So you see that when we complete one step and we set it as completed, we are resetting the previous step. That way, if another part were to come in right now, well, it's too early for one to come in because the part is still setting in the drill station, so you couldn't bring another part in behind it because cylinder 1 and 2 are still extended. Now step 1 has been released. But if you back up here and look, see cylinders 1 and 2, they're still extended. Remember, these are single solenoids. So if output 1 and 2 are on, the cylinders are extended. So let's move back down here. Now what we're doing is when cylinder 4 is extended, we start a delay of 1 second. And the reason we do that is so that the bit can continue to turn in the bore and clean out the debris. So let's toggle this bit on, and when we do, we're going to de-energize the solenoid that extended cylinder 4, and once it's retracted, we're going to say step 4 is complete, and we're going to clear or reset, unlatch step 3. Okay, so we go down to the next. You notice that little delay there was the time it takes in the simulation of the cylinders. Down here, cylinder 4, this time delay to retract. So when we turn output 4 off, we start a 1.8 second timer, 1800 milliseconds, and then we're saying that is the time it takes for the piston to retract and turn on the cylinder 4 retracted proc switch. Now what we're waiting for is cylinder 4 to be retracted. Well, it actually is, but we haven't released this logic yet. So once we do, what's going to happen is we're going to retract cylinder 1 and cylinder 2 by de-energizing, resetting, de-energizing those outputs so the spring return on the valve spool shifts it back to the retracted flow and causes the cylinder to retract. And then after a delay, you'll see these two bits come on saying that cylinders 1 and cylinder 2 are retracted. So we complete step 5 and we clear step 4. So we'll do that. Now you see after a delay, once these turned off, after a delay, you see that the retracted proc switches sense the piston in the retracted position. So going down to the next step, cylinders 1 and 2 are retracted. So picture in your mind, you have a part sitting in the drill station, and cylinder 2, cylinder 1 was a stop out on the conveyor, but cylinder 2 had that part clamped into a V-block to get a hole drilled in it. So cylinder 2 is now retracted. With cylinder 2 retracted, we can extend cylinder 3 to push it out of the drill station out onto the finished product conveyor. So let's turn that logic loose. You see after a delay, then we see cylinder 3 extended proc switch is made, and we're saying that we complete step 6, we clear step 5, but we also say that there is now a part at cylinder 3 extended position. Once it's at that position, then we want to retract cylinder 3. We do that by resetting that bit, clearing that bit. That turns off output 3, and the spring return nature of the valve reroutes the air pressure to retract the cylinder. So let's turn this loose. And after a little delay, we retract cylinder 3. Now this rung, we don't put a step in it because it's kind of an unconditional thing to do with the downstream call and cylinder 5. Remember, I told you in a previous discussion that we can actually live without cylinder 5, and it's in there at the behest of the downstream station wanting some actual physical barrier to prevent parts from coming down that conveyor no matter what. They're not ready for them. They want cylinder 5 extended. The downstream call actually comes from them. Now, we're using input 5 here to turn it on and off for the downstream call, but in reality, this would be the state of a bit in another controller with a discrete line coming to our input 5. So it's not a switch. It's actually a signal from a downstream station calling for parts. So there's nothing for us to do with this wrong. So we step on down here, and we can see that when we de-energized output 3, at some point we were going to have a part at cylinder 3 extended. And of course that got turned on right here. So when cylinder 3 extended proc switch was made, we said there was a part there. When there was a part there, we gave it a delay, then we retracted cylinder 3. So this being true, part at cylinder 3 extended, means there's a part sitting there. And because there is no part in front of photo I5, remember that's on down the conveyor a little ways, right by the stop that's controlled by this cylinder right here. So cylinder 5 is extended, and that photo eye is right in front of it. So when we turn this loose, what we're saying is that there is a part at cylinder 3. There's no part in front of photo eye 5. Cylinder 3 is retracted. So let's go ahead and turn on the finished product conveyor. When we do that, we're actually going to turn off part at cylinder 3 extended when the conveyor comes on, but I can't do that until I've released this next step. In other words, if the conveyor is running and there was a part at the end of stroke cylinder 3 extended, it won't stay there long. It's getting pulled by the conveyor. So let's release the next step, and we don't clear this part until we see it show up here. So in other words, that's really, in the other code that we showed you earlier, we had this as a hard wired input to a photo eye. In this case, we're using a virtual sensor, and we're using logic to remember there was a part there. So when I turn on input 4, that means the part has arrived from here to here. But I can't turn that off until I see it here. So I turn on input 4, and when I do that, the finished product conveyor is turned off. Now, if I go down here a little bit further, here's my no activity on the finished product conveyor. And you see step 6 cylinder 3 is still extended. So I'm going to clear that. I still have cylinder 3. The part is sitting in front of photo eye 4. To get rid of that, I'm going to have to turn on a downstream call, and then the photo eye changes state. It clears this bit, says no activity, and we start our timer. Once that timer is complete, we shut off the conveyor. Now, here's an advantage to using this single step bit. Notice that this bit came on saying that a finished part is leaving. Without the single step bit in there, this would have went on and off within one program scan. You might never have seen it come on. So I'll show you. I'm going to release this, and that will clear these. In other words, it'll reset all these things back to the off state, but it won't reset these steps. Step 7 and no part activity until I release this rung. Okay? And notice when I did that, I have logic in here that when I release single step 11, or I turn it on, and there's a part leaving, I put a 0 into the part number, that's for the barcode scanner, and I move a 0 into single step, which clears all of these single step bits that I turned on in order to get it to sequence through here. Very simple. Now the HMI logic, I didn't go through this, and there's actually 3 different things here. And the first 7 rungs are a kind of a detailed approach to this. Rung 8 is a separate way to look at it that is really kind of a consolidation of the first 7 rungs. And then rung 9 is just the steps. Okay, in the next discussion, we're going to look at the seal-in logic. So the seal-in logic is the ultimate goal.